I guess that's all we get. Oop. Okay. Then good afternoon, everyone. Or most everyone. Some words of wisdom here. Before we begin, victorious warriors win first and then go to war, while the defeated warriors go to war first and then seek to win. The difference, of course, is planning, right? Being prepared for what you are about to undertake. And that will lead you to success. So, with that in mind, here is what I have prepared for geometry for today. We're talking about surface area. And almost but not quite sneezing. I hate when that happens. Anyways, yes, if you have not already, please go ahead and join the Zoom so you have a visual. And surface area, as you read about this weekend, is nothing more than putting together multiple areas. It all begins with area. If you can find the area of various figures, you can find the surface area of a figure. Right? It's not any new challenge above and beyond that. The only trick really is just to recognize which shapes and make sure you keep track of all of them. That's probably about it. Now, the SAT does a very lovely thing for us. It provides these formulas. This is the exact image of the reference formulas provided at the beginning of both math sections on the SAT. And you can see it has the area for circles, rectangles, and triangles, as well as the volumes. We'll get to those tomorrow. So you do not need to memorize area formulas. They're already here, okay? However, you have probably been using them since like, what, 3rd grade or something? I would hope you already know these. If not, we're still going to continue to mess with them. So through sheer repetition, they should stick in your mind. Again, you don't need to memorize them. I will also be providing you this same reference sheet on the test, and you'll, of course, have your own notes to refer to during the test. But is it still worth memorizing? Yes, absolutely. Just for the sake of saving you time. If you do not have to flip back, look it up, and then flip back to the problem, write it down, that saves you precious seconds that add up, certainly on the SAT. So I would encourage everyone to go ahead and get these locked in their brains anyways. That said, once you have those basic pieces, now you can build off of them. And the surface area of a three-dimensional shape is nothing more than putting together multiples of these two-dimensional shapes. And I'd say the best way to think about it, and one often brought up as an actual word problem, is how much paint would it take to paint this, object? If you wanted to cover every surface, paint it all a new color, right? How much paint do you need? And you have to know, okay, what's the area, in square feet or square centimeters or something? How much paint do you need? Do you need to get the big can, the little can, a jumbo size, giant 5-gallon bucket of paint? So it's a good practical tool to have. So here's what we're going to do. We're going to run through our known three-dimensional shapes and break them down, which is really how we defined them in the first place, as to what shapes they are composed of. Right? If you want to know the surface area of a prism, then the first thing you need to recognize is that every prism is simply made out of 2 matching polygons and a bunch of rectangles. Okay? So all of the lateral sides, the rectangles, you can find that area. Use the rectangle formula. The other two polygons, make sure you count both of them, unless the problem says, everything but the top of the box or something like that. That depends on the shape of the polygon. If it's a triangular prism, obviously use triangle. Square, use square. Right? Other polygons, we'll get to other polygons actually. Okay? That's all a prism is. Pyramid, similarly simple. There is the one polygon base and a bunch of triangles. So you need to combine the formulas for here's all the triangle sides. They will almost certainly be identical. And then the one polygon base, so use whatever formula is appropriate depending on that shape. Okay? Cylinders are a little bit trickier. They are comprised of two circles, one on top, one on the bottom, of course, and then the rest of it, remember that soup can label, if you unravel it, turns into one giant rectangle. The trick being that the height matches the height of the cylinder, but the length of that rectangle is actually the circumference of one of the circles. So you will need both the area and circumference formula for circles to find surface area of a cylinder. All right. Questions there so far? Where is there the basic area question on the SAT? They won't just ask you to find, hey, what's the area of this trapezoid? That's way too straightforward. Most of the time, they're going to go 3D on you and ask you a surface area or volume question. Makes it a little bit more involved, but not actually more difficult. It just lengthens the computations. They like to try to waste your time that way. All right, so what we've got for today are a few surface area practices. I want to draw your attention to number 5 in particular, this being a pyramid of sorts. So we have the base, here is a hexagon, and then all the triangles up top, which means we need to find the area of that one hexagon plus 6 triangles, right? And that would give you your total surface area. So that's like your first step analysis. What is this shape composed of? And then you break it down. All right, how do I find the area of each one? And the reason I bring this one up is twofold. One, make sure you're given the correct measurements to find the area of your particular shape. In this case, we have S, which is the side length here, which is also the side length here and the side length there. It's a regular hexagon. All the sides are the same. And notice that brings us to my triangle here, which I could redraw it on the side. It would be something like that. Imagine that was actually a straight line there. So this would be S. And they give us this dashed line here, L, that makes a right angle. Look for that right angle. That is very important because that's what you need to actually determine your height of your triangle. In this case is actually L. The height of the triangle has to be perpendicular to its base. If they give you this measurement, that does you no good as is. Right? You can't use that in your area calculation. You would have to, actually in this case, you'd have to use a little bit of trigonometry to find out what that height actually needs to be. So always double check that. And then second, how do you find the area of the hexagon? Wait a minute, Mr. Apple, hexagon isn't on the list of provided formulas. What are we going to do there? Have no fear. Every polygon can be broken down even further. So just like the 3D shapes, we're going to break them down into their 2D shapes. And if you end up with a 2D shape that is not a quadrilateral or a triangle, and therefore, I don't have the formula on my list, don't panic, because it can always be turned into a simpler shape. What is the simplest two-dimensional shape we have? Anyone? Oh, I've said this in class before. Everything is made out of what? When we were finding the interior angles, we drew a bunch of extra diagonals inside the shapes. Why? What shape did we break them all into? I stopped for one participation question, and you're bombing it, guys. Come on. Take a guess.
Triangle?
Triangles, very good. See, you knew it all along. Regular polygons are made out of triangles. Everything can be made out of triangles, in fact. So we're going to use that to our advantage, right? Because we can find the area of a triangle. And so if I break the shape into triangles, find the area of all the triangles, and then add them all up, I'll have the whole shape, right? Okay, check this out. Here's a regular pentagon. Right there, I even marked all the sides for you, so you know it's regular. And they give us some measurements here. And what we're going to do with those measurements, what we're going to do with the pentagon is we're going to break it into triangles. Now, before we did this, we connected the diagonals. But this time, I want to break it into all identical triangles. So I'm going to draw from the center out to each vertex. And we're going to slice this guy up like a pie. Look at that, delicious, right? And now we can see, hey, since all these sides are the same, all these sides are the same, all of those triangles are going to be congruent to each other. So really, this the area of my pentagon is just 5 times the area of the triangles, right? And that triangle is 1/2 a base times a height. So now I just need to figure out which one's base and height of the triangle. So they tell me apothem of 2.1 inch and side lengths of 3 inches. Okay, let's start with the easy one first. Side lengths are, of course, these guys, right? All of these are sides S. So looking at one of my triangles here, I'd say that's one of the bases because it gives us the side of the triangle. So let's substitute that in. Instead, we have 5 times 1/2 times S. And where does my height come from? That comes from this possibly new term, apothem. It was in your reading. You should have that definition in your notes. If you do not, write it down now. The apothem is a segment from the center to the side of a polygon, making a right angle with that side. It is always perpendicular to the side, by definition, which is really convenient because now look, I've got a height of the triangle perpendicular to its base, exactly as it needs to be. So our height of our triangle comes from the apothem of our polygon. So now it becomes much simpler. We can just substitute all our numbers into here. 5, not equals, times 1/2 times side of 3 times apothem of 2.1. And 3 times 5 is 15 times 2.1, 31 15.5? And divided by 2, 15.75? Someone with a calculator can double check my mental math that is, I didn't do the mental math, I just remembered it from last class. Right? That's actually not too bad then. So long as they give you the apothem, right? So just like looking at that pyramid there, they had to give you the proper slant height, right? Careful with the pyramids, right? Because I need the height of the triangle that goes up the middle. I don't want the edge of the triangle, so I don't want the edge of the pyramid. Neither do I want the actual height of the pyramid, the height of the pyramid measured from the base up to the top, straight up. Right? So it's usually drawn as a dashed line inside the center there. I don't want that height. That height does me no good. I need down the length, down the middle of a triangle. So I got to find the area of that triangle, okay? Similarly, I don't need to know this length from center to vertex. I don't care about that. What I want is from center to the side, the middle of the side. In this case, it will hit the midpoint, perpendicular, so it's actually the height. Okay? So there's your trick for any polygon. Slice it up like a pie into triangle pieces, and then find the area of all the triangles, and add them all back up. That is a guaranteed method to work every time. You can stop there and be done and say, oh, I'm going to take that piece of knowledge, apply it everywhere. That'll work. Now, if you're the type that prefers more formulas, like, ooh, I want an even shorter shortcut that I could jot down, also commit to memory. They won't be on the formula sheet, so it'll be on you to remember this. Right? Instead of the process, is there an even better shortcut we can use? Yes, there is. And we are going to start with this middle formula right here. The number of sides times 1/2 times the side length times the apothem. And what I'm going to do with that is first I'm going to generalize it. So for any polygon with n number of sides, we have n times 1/2 times side length times apothem. Okay? And the number of sides times the side length. Think about that for a moment. That's, if I have 5 sides here, that's s times 5, s plus s plus s plus s plus s. That's just the perimeter, right? So one shortcut formula for the area of a polygon, a regular polygon with n sides, is 1/2 apothem times perimeter. And that's pretty handy to know, especially if, say, they give you the perimeter to start with. It's kind of a neat one. Okay? But again, not something you have to memorize, not something you even need for this worksheet. You can just work it as a breakdown of triangles, but that is the derived result. Any questions so far? No? All right. Then I will leave you with the rest of the time to work these 9 exercises. Okay, number 5 being the hexagonal pyramid, possibly the trickiest. 7, watch out these sides because it's they chop the top off of this pyramid. You're left with trapezoids here, which is not one of the standard ones they give you there, but it should be one you have in your notes. Okay? And then watch out for number 8. Anytime there is a hole in something, the SAT loves to do this just to make your life more complicated. Okay? As if finding the surface area wasn't enough steps. They're like, oh, whoa, whoa, whoa. You can't just find the surface area of one shape. You need to take one shape and another shape and then add and subtract the two of them. Okay? Imagine you had to paint this thing, a solid cylinder, okay, with a square hole cut down the middle. You've got to paint all around the outside. You've got to paint the top. You've got to paint the bottom. The top and the bottom are circles with square holes in them. The paint is only going to go there, right? So you have to calculate the circle and the square and then subtract, all right? It seems obvious when you say it out loud, but some people miss that. But down inside the cylinder, you still have these rectangular faces. If you were to paint this object, you've got to paint all around the outside and then paint down on the inside. Okay? So all those rectangles will get painted. You need to add those up to the surface area as well. Okay? So there's extra tricky here. You got some pieces to add and some pieces to subtract. Make sure you keep track of which is which. Okay? But all that stems from just giving it some thought. What if this was a physical object? Pick it up and move it in your mind. That's where the visualization techniques come in handy. All right. That's all I've got for you today. Final call for questions. Clarifications. Anyone not know what they're doing? No? All right, then I leave you the rest of the time to work.